Configure VMware clusters and resource pools. All right, now we're on to the really exciting part. We've got the hardware more or less configured at this point. We've got some VMs up and running. We've created a vApp. We've installed VMware tools. We know how to vMotion at this point, but you know, the real exciting part about running a vSphere environment is not just the vMotion piece. It's all the other stuff that sort of wraps around vMotion, at least in my mind, that makes it automated. If I had to sit and go and migrate each VM one at a time based off of my own internal gut feeling, well, I'm probably not going to do as good of a job as a mathematical model that has certain monitors that looks and sees, okay, well, you need this much CPU today and that much memory today, and I need to rebalance based off of that. That's what the job of a cluster is. If you're familiar with the terms HA and DRS, or high availability and distributed resource scheduling, these are the two functionalities that a VMware cluster is predominantly known for. Once you have a cluster in place, then you can create some resource pools that provide hard boundaries around the resources that you can assign to various people. We're going to talk about all of that in this nugget. You will leave this nugget having an understanding of the role of VMware clusters and also the resources that are required for HA. I'm going to tell you what the implementation tasks are, but I want you also to understand some of the more design, some of the more strategic tasks as well, because I see it happen all the time where people turn on HA and they don't do it smartly, and so consequently they end up creating problems for themselves. And I don't want you to create a problem by turning on HA and TRS. You'll also understand what EVC is, or Advanced vMotion Compatibility, which becomes particularly important as your size of your cluster grows. You essentially want to create these islands of vMotion capabilities so that you don't have a cluster that thinks all of your hosts can vMotion with each other when in fact they can't. In this nugget, we will spend time creating and completing the initial configuration of building a cluster, a very interesting thing to do. We'll do the same thing with the resource pool. We'll take a look at those same shares, reservations, and limits. The resource pool manifestation of these things flows right in from what you learned in the individual virtual machine configurations. We'll take a look at some cluster behaviors, and then we'll also take a look at storage DRS. So I think you're going to find this particular nugget to be really exciting because it's a lot of the really interesting pieces about really why you would create a vSphere environment in the first place. And before we get there, I want to bring up a series of pictures because I find that the pictures really help people understand what this whole cluster thing is. Right? And a cluster in VMware speak is a little bit different than a cluster in Microsoft speak. It's not necessarily a shared nothing cluster so much. It performs different functions too. A cluster in VMware speak is designed to do two things. It's designed to do HA, or high availability, and DRS, or load balancing. The first picture here shows you, all right, I have 3 servers. One of which has failed, 2 are healthy. All of these 3 servers have their virtual machines that are sitting on shared storage. They're all talking to this common network here. And so one day, poof, one of the servers just fails. Okay, motherboard dies. Somebody pulls a power cable out. You drop your coffee on the server. And so consequently that server fails. Now when it fails, there are a bunch of virtual machines, the brains of which are up here and the bodies of which are sitting down here in shared storage. When that server fails, what happens? Well, I have an HA cluster that is configured. The virtual machines are going to die. Right? They are going to power off because there is nothing preventing them when that server goes down. You yank the power cable out, right with this configuration, there's nothing in place to protect that. So these virtual machines power off, but remember their bodies are still sitting over here in shared storage. So they're going to have to power back on in order to continue operating. And powering on, powering on a virtual machine doesn't take that long. So they power back on, but the HA cluster says, oh, wait a minute, this server's failed. Go ahead and power these machines on the surviving cluster hosts. So this is what we think of when we're really considering what HA is. HA is, I want to protect myself from a failure of a piece of hardware and then move all the VMs onto surviving cluster members. Now, this is somewhat different than in the DRS situation. Okay, so let me flip over here to the DRS slide. There it is. And my DRS picture here shows you, all right, I've got 2 hosts here because it's just easier to see than with 3. But it can be up to a very large number of hosts. And I've got one host that's overloaded. Okay, I got, I don't know, 1, 2, 3, 4, 8 servers on there. That's a lot of servers to have on one host. The other host has only got, what, 5. So the other half of my VMware cluster is to take one or more of the machines and then move them over to the underloaded hosts to balance the resource use across all the hosts in the cluster. Simple stuff. Now, when I turn on these functions, obviously I have to have licensing for them. I also have to have really an awareness of how much hardware is available so that the cluster can support the needs that I want to have. Right? If I only have 2 hosts in my cluster, there's not that many places for the virtual machines to go. And so when you're building clusters, you got to kind of pay attention to what amount of hardware you're going to apply into that cluster. And here's my picture. I got 4 hosts. In order for a cluster to have the resources available to support the failover needs of a lost host, I need to have, and this is a sort of introductory statement, I need to have at least 1 host's worth of available resources that are left as unused to support the loss of a host. Okay, now let's think about this. So this is, each one of these 3 is a host that's running at 100% capacity, kind of extreme example here. Let's assume all 4, if this host fails and it's also running at 100% capacity, well, there's nowhere for the virtual machines to go. The other hosts are operating at 100% capacity, so if I move the virtual machines off of that failed host onto the other hosts, well, I got a problem, right? When you're building a cluster, it is important for you to take into account all of the needs of the cluster. And those needs include having resources that are set aside as unused. Okay, in this cluster, this is a better prepared cluster. Okay, I have 3 hosts. All 3 hosts are running at 100% capacity. When one of those hosts fails, I have one host whose amount of resources is set aside as reserved, and so when this host fails, the virtual machines can easily go over to this host, again assuming that they're all the same size, and this host can process the needs of that VM. Very easy. This is one of the correct ways to create a cluster. Now, I will tell you, you don't have to set aside one host. You're not going to just say, okay, server 7 is our reserve. No, that's the clustering in vMotion or in DRS is far smarter than that in HA2. What it does is it takes all the resource reservations across all of these hosts and sort of adds them into a big equation. And then it chops them up and balances this reserve space across all the hosts in the cluster. There's no sense in unbalancing them and then leaving one reserved empty. No, why don't we just use, I don't know, 75, 75, 75, and 75% of those resources across those 4 hosts. And now I've got a really much better mechanism of balancing that load. So to start out with, we're going to create an HA cluster here. That HA cluster is going to have 3 nodes. The 3 nodes will be more or less similarly configured, at least enough for our purposes. But we're doing so that one node has the excess capacity in place, or the cluster contains one node's worth of excess capacity to support the failover needs in case I should lose a host. Got that? All right, let's begin. So back here in vc.company.pri, this environment should look a little bit different than what you saw in previous nuggets. You'll see now we have ESX1, 2, and ESX3, which I've built this. It's another host. It's got the same networking configuration down here, same 3 data stores, 2 switches, 1 VM kernel port group, or 1 VM port group, 3 VM kernel port groups for storage and management network. So Same kind of thing, right? ESX1, ESX2, ESX3. And I put these together because doing your cluster, you almost have to have 3 hosts, because if you create a cluster with HA turned on, I have one host that does things and another host that's waiting for the other one to die. So it's kind of nice to have 3 hosts to play around with. The way that you begin this process of creating a cluster is by right-clicking and choosing New Cluster. Now we have to give it a name, our cluster. And we have to turn on the features that we want. Now these features you obviously have to be licensed for, and you have to have HA to use fault tolerance, that we'll talk about a little bit later. Once you turn on these features, then you can then work within them, obviously, do some initial configurations associated with those features. When you first turn on DRS, a lot of administrators, this is the load balancing piece, a lot of administrators get really kind of itchy at fully automated, as the term down here for automation level. And so a lot of them start out with manual. Completely understandable. If you've not played with this before, the notion that DRS is just going to move your virtual machines around by how it seems it needs to can be a little itchy, I think. Now I'll tell you that there are environments all over the world that are using fully automated mode, and when they turn it on, it just works. So as long as you have your host, and you can guarantee that you have your host similarly configured, setting it to fully automated is a relatively safe thing to do. Now when you do that, you have this little slider bar that determines which priority recommendations the DRS will actually implement in order to maintain balance. I like to think like DRS is one of those tables that only has one leg in the center. And each of the sides of the table corresponds to one of the hosts. And each host is going to have a certain weight to it that's associated with, well, how much stuff is trying to run on that host. And so if you think about it, you've got this sort of table that's trying to stay in balance. And I got one host over here that gets a little hot, and so the table goes down into that direction. And maybe this one lightens up, and the other one on the other side starts to get a little hot because maybe there's a logon storm, or somebody sent out a big email to a bunch of people, and so it's unbalancing this way. And so this table's always constantly trying to rebalance itself so it can sit on that leg in the center. Now when we configure fully automated mode, DRS is fully empowered with which to make all those decisions on our behalf. When I set the migration threshold, this determines how big of a movement do I need to make in order for myself to get my table back in balance. Right, if I only turn on priority 1 or 1 and 2 recommendations, well, I'm only going to make the big moves that are about to make that table tip over. Right? And as I get more towards aggressive, I'm going to start applying the recommendations that maybe have a very much less of an impact on how balanced that table is going to be. So you kind of have to be careful here about whether you want to just worry about the big stuff or if you want to worry about the little stuff also, because each move there's a performance tax to it, there's a resource tax to it. A lot of us just leave it at 3 and run with it. I'm going to set mine for 3 because it's just, like I said, it's where most people set theirs. Now DRS also has power management too. This is one of those technologies that not a lot of people use. Neat in concept, a little extra itchy in terms of how it might make you feel, but and really, arguably, you should almost never get to the point where you never need to turn it on, because that means you've overbought on hardware. The idea with power management is DRS's job is to distribute the load equally. Power management says, okay, while distributing equally, also try to consolidate onto as few servers as possible. So if my resource reservations for different virtual machines are such that I can consolidate them onto a smaller number of hosts, and in my 4-host cluster get to the point where only 3 of them are being used, well, why don't I just power off the extra host? Great if I've got 32 hosts in a cluster and I've just overbought to prepare for the future. I can just turn this thing to power off, and it will automatically turn those hosts back on whenever the need arises for the resources that those hosts supply. A lot of us leave this turned off. The host has to support power management. They have to have, wake on LAN, IPMI, or ILO to power them on. Again, if you have to turn this on, you probably overbought when it relates to hardware, but that's okay. I'm going to leave this off at this point because you now know what you need to know associated with power management. HA, remember, HA is different from DRS in that HA is responsible for high availability. Its job is to protect against the loss of a host. To turn on HA, right, we have to check this checkbox here, enable host monitoring. Poof, it turns on HA. The second piece is this admission control. Now, it is entirely possible to turn on HA, but then to turn off all of the mathematics that determines whether or not you actually have enough resources or not. If I set this to disable, it will allow VMs to power on even if they violate availability constraints. Now, you got to be careful here. Remember our prototypical cluster. Not this one, but the other one, where I've oversubscribed my cluster, and so now I've got this host that fails, and I got nowhere for virtual machines to go. Now, what admission control does is it says, I'm going to be the traffic cop, and I'm going to say, no, you can't power on because I don't have enough resources available to protect myself in the case of a failover. Some people, some admins, will turn on HA and then disable admission control because they think they're doing themselves a service. Wait a minute, I don't want to be told I can't turn on resources. That's why I bought the hardware for. Well, if you do that, you're probably going to create a problem downstream as you start adding more virtual machines. Turn on HA. When you turn on HA, the bottom admission control policy becomes important. This is arguably some of the worst named settings I think I've ever seen in my entire history of IT. Host failures the cluster tolerates. Interestingly enough, a difference between version 4 and version 5 is that the word "the" is now available, which I think improves what this means a little bit better. Host failures the cluster tolerates essentially means out of all of the hosts that comprise that cluster, how many hosts can fail that the cluster can protect against. Right? Typically, this is set to 1. If you have a very large cluster, you might put it at 2. But when you would set this to 2 is when you think that the possibility that 2 hosts would fail simultaneously and you want to protect yourself against that. That's when you might set this to 2. Remember, this cluster can tolerate the failure of no hosts. Right? There's nowhere for it to go. This cluster, conversely, can tolerate the failure of 1 host. I'm going to set aside 1 host's contribution of resources so that I can tolerate the failure of 1 host. That's what host failures the cluster tolerates means. Now, this is a good thing to do because if you turn this to 1, you're automatically protected against any host. Be careful, though, because that also means the largest host. So if you have dissimilar sizes among your cluster hosts, you're going to set aside the resources assigned to the largest host because you have to protect against its failure. Now, not all of us have necessarily the requirement that we protect all of our VMs. We don't have to protect every VM. Maybe we just protect some of them. Now, in a 3-host cluster, right, I am protecting 1 host, or I could set myself to 33% of CPU and memory resources that I'm protecting. Okay, these two are now equivalent. I'm protecting against 1 host's failure. Or I could get a little more sly with things, and instead of setting this to 33, maybe set this down to 20. So instead of trying to protect the entirety of 1 host's contribution, I'm actually going to set this to 20%, which is a little bit less, and that allows me to, well, to identify. I want to protect some virtual machines, but not all of them. I'm going to set this to 20% for now because I want to show you something here in just a minute. If I set those to 20%, I have to be careful about these other settings here, specifically the VM restart policy. So when I set this to lower than 1 host's contribution, I then am going to have to go to each virtual machine and identify which ones should get restarted on the surviving cluster member when the failure occurs. Now, this sets the default policy, and I usually set this to low. So by default, every VM will restart with the same priority, which is low. And I can go then and set medium and high on my really important VMs so I know that they're going to fail over first. I also have to be conscious here of if any of the hosts should somehow get isolated from the other hosts, their management network gets isolated. Now in vSphere version 5, this is a little bit less of a problem because I have a secondary backup channel called a heartbeat data store, a heartbeat network, that protects myself against a host isolation response. When I have a host that's isolated, the VMs are sort of stuck on that isolated hosts. It used to be the suggestion was to shut down those VMs. Now, because of the heartbeat data stores, generally we leave them powered on. Host isolation response is you have either experienced an isolation event and hate it, or you've never experienced it. It's a really painful day. Over here, I can choose, okay, I'm not concerned about the virtual machine so much as the stuff inside the virtual machine. Okay, VM monitoring restarts individual VMs if their VMware tools heartbeats are not received within a set time. I have to be careful with this, because if I turn this on and for some reason I disable the VMware tools service, well, I'm going to restart the server. And then also, what is the monitoring sensitivity for when the host in the VM has not been received? So I usually caution people about this one. Enable this, but only if you're sure that your VMware tools aren't going to be the source of a problem as opposed to the solution. Now, I mentioned the enhanced vMotion compatibility piece. And the idea that you have to have hosts that are kind of close to each other in terms of family and stepping, right? Your Core i7s and your Intel Xeon first generation hosts are not going to be able to vMotion with each other. Your Core i7s and your Core, I don't know, whatever the next one is probably going to be able to, because they're fairly close to each other. Now, this creates the problem where I might end up with a set of hosts I bought in 2011 and a set of hosts I bought in 2013. And the 2011 hosts can talk to each other, and the 2013 can talk to each other, but they can't talk among the two groups or between the two groups. I have to be very, very, very careful so that I don't create a cluster where the cluster thinks that I can move things around, but I can't because I can't actually vMotion. That's what EVC does. EVC says, all right, here is the minimum level of hosts that I'm going to support in this cluster, and before I'm even allowed to add a host, well, it's verified against this list. By turning on EVC, I set kind of the minimum bar for admission into the club, into the cluster, and that protects me against that situation where I have a cluster that the cluster is making decisions, assuming that everybody can vMotion, even though not everybody can vMotion. So I'll set this to, I would have you set this to whatever your minimum standard is for your cluster. I'm not going to turn this on because I have virtual machines. But you would probably want to turn this on in your environment to protect yourself against having two hosts that can't vMotion with each other. Here, just store the swap file in the same directory as the virtual machine. It's generally a good idea. You only do this other one in a different data store usually if you're being told to do that. So I'm going to leave that the same and then complete adding this cluster. There we have it. Poof, there's a cluster. Once I create the cluster, the next step is to actually add in the hosts into the cluster. So if I choose add host, I can add hosts right into the cluster here. Now, this assumes that I don't have a host yet, like I'm adding a new host brand new. The hosts that are already part of the data center, I can literally click and drag into the cluster, and that will bring up the add host wizard here. Now, I have a couple of options. When I do so, I can either put all of the host's virtual machine in the cluster's root resource pool, or I can create a new resource pool whenever I do this. I generally just click the first button here because I'm going to create my own resource pools a little bit later. So there's the first one. I'll do it again for the second one. This will kill all the vApps on the host whenever I do so, but as you saw with vApps, there's not that much to deal with. You can recreate a vApp fairly easily. And then I can do it again for number 3 here. Very simple. Now I want you to notice something. Right, I've created a cluster, right? And you notice how the hierarchical view of this cluster is somewhat different than what it looked like before. In the previous version, right, each virtual machine was underneath a host in the hierarchy. And these VMs are still on those hosts, right? If I click here on VM1, that's still on ESX1. But you notice the visual separation here. It's designed to help you come to the, I guess, the realization that once I'm in a cluster, I really don't care anymore where actually my virtual machines are stored. Once I put them in a cluster, I just know that they're part of a cluster, and that's all I have to care about. Now, the DRS functionality of this cluster is at some point going to go about making decisions about where things should go. So here is my DRS tab on the cluster. These are the recommendations. I have fully automated. My power management is turned off, and I'm applying priority 1, 2, and 3 recommendations. So right here is when the next DRS pass comes through, which happens every, I think it's every 5 minutes. When the next DRS pass comes through, it's going to identify if I've really got good balance across all the hosts in this cluster. And if it doesn't, it's going to generate some recommendations, and it's going to automatically apply them because I've set the automation level to fully automated. If I set this back to partially automated or even manual, the next time that those recommendations come through, you see if I run DRS here, I doubt these recommendations will actually appear because I only have one VM powered on. But the next time these recommendations come through, I'll have the option of selecting a recommendation and choosing to apply. Okay, so that's how DRS functions here. This is how we create a cluster. I mean, that's all there is to it. Once you do create that cluster, you can go back and actually edit the settings of the cluster to see a little bit more details about what we did. This we've seen before. All of this we've seen before. There are some advanced options here. There's nothing really to talk about. I mentioned the VM restart policy. Okay, and I told you that I set the default here to low. Well, let's assume that my VM6 is a high priority VM now, because I've reduced the number of resources I'm protecting. Well, I know that VM6 is going to be one of the first VMs to move if I lose one of those hosts. So this is the final piece of that original conversation about setting up HA, protecting as much of it as my dollars can afford, and then setting the restart policy on those VMs so that I'm restarting the VMs based in order by the business rules. Right, so I know that VM6 is really important in my business, so do it first, and then do the app here as a medium setting, and then VM1 as a low setting, because I don't really care about that. And same thing with host isolation response. Maybe this one's important, so leave it powered on, but this one's not important, so powered off. You want to keep an eye on this as your virtual machines, as you start adding virtual machines. Do you want to turn on the VM monitoring or application monitoring for your VMs? You see here we get a little bit more stuff here that we can adjust on a VM setting. I also talked about how HA has a little bit better of a configuration architecture as it relates to host isolation. So let me go back to my picture here for just a second. So here's my picture. And I have an isolation problem, right? Let's look at this one, for example. Maybe instead of this server failed, this server actually got isolated from the rest of the servers. Its management network is disconnected. Its virtual machines are still running, but its management connection is disconnected. So vCenter can't talk to the ESX machine, but the VMs are still running. It's just lost its management connection somewhere. That's what an isolation response is. In version 4 and before, this is a really bad day. Right? An isolation response meant powering down the VM, sometimes forcibly, so that we could release the VMFS locks on them down here in the shared storage, and they could be HA migrated over to a new host. Okay, bad day. This could happen if somebody unplugs a cable, right? Or somebody hiccups the management network. This could happen. So what VMware did in version 5 is they created a secondary sort of backup channel. That backup channel uses a data store as the mechanism, and it's called a heartbeat data store. Okay, the heartbeat data store is only used in the case where you end up losing the management network connection, and I need to just keep the cluster contiguous enough, integral enough, so that I know that I can continue to talk to those other members of the cluster. Now, I can select any of the cluster data stores, taking into account preferences, so I would prefer one or the other. Or I can select any cluster data stores or from preferred data stores here. Generally, you might just leave this to itself. It will choose a data store of the ones that are available that it thinks is best. The one thing you got to be careful of, the heartbeat data store works the best when the data store that is selected is available to every host in the cluster. Now, most people configure a cluster so that every data store can be talked to, can be communicated with every host, but not always. So if you do have data stores that not every cluster member can talk to, don't use that as your heartbeat data store. One little piece of advice there. That's HA. On the DRS side, we've seen the automation level here. I can also set up groups. Okay, this makes more sense if I take a look here at rules. These are what we call affinity rules. And in my affinity rules, I have the option of selecting whether I want to keep the virtual machines together or separate them out when I'm going through doing my load balancing. Now, think about how this might work, right? So I've got load balancing. I've got virtual machines that are moving around, right? Maybe they're my two domain controllers, right? They're moving around, so they're load balancing across all those different hosts. Well, if they're domain controllers, it's not a good idea for them ever to land on the same host, because if that host fails, I've lost my domain. So setting up a separate virtual machines rule would allow me to choose which VMs would always be segregated onto different hosts. Two domain controllers. Great idea. Separate them. Conversely, a keep virtual machines together rule is great when I have two VMs that I want to keep on the same host. The VApp example from before is a great example. The database needs to talk to the app server, which needs to talk to the web server, and if I keep them all on the same host, their networking occurs over the bus speed, right, over the VM bus and not over the network. So useful for performance. The third one is a virtual machines to hosts rule. And for this, I actually have to create some stuff here, a cluster VM group and a cluster host group, which is what this groups manager is. So if I have a, I don't know, let's do VM6 here in this DRS group, VM6 group, right? And I want to say, okay, here's a host group. I want to say ESX1 and 2 are in this host group, sum of my hosts there. When I come down and create a rule, that would be a virtual machines to hosts rule. The VM6 group must run on hosts in the sum of my hosts group, or should, or must not, or should not. This is essentially a much more granular version of the other two affinity rules. Okay, and over here in Groups Manager, I can do some more information. The same thing. This and that is the same thing. But these two are the ways in which I identify as stuff moves around and is dynamically shifting around inside of my cluster to make sure that virtual machines don't end up on the same host or do end up on the same host. Do I want to set automation levels here that are specific to DRS? Maybe now, instead of just having the entire cluster fully automated, I want to have just certain VMs that are fully automated. Power management settings, just like we saw before, and specific host options with power management settings. EVC settings, right? I'm still disabled here, but you would be enabled, and then the swap file location. So all of this are the settings that you have to be conscious of whenever you're creating that cluster. And I will tell you, you can make some really painful, awful decisions that would really cause some problems here. So be very intelligent whenever you create this cluster. Try not to create too many affinity rules. Especially in smaller clusters, affinity rules can cause some real problems in that it doesn't give the cluster, it reduces the number of options that the cluster has for where to put stuff. Same thing with shares, reservations, and limits in resource pools. You know, a resource pool is effectively a piece of a cluster. Okay, my cluster here, for example, has, if I look at the summary here, it has, what do I have here? 22 gigahertz of CPU, 10 gigabytes of memory and 550 gigabytes of storage. That's the maximum supply of resources that my cluster has. So a resource pool then, as I mentioned, is a piece of that cluster. Well, let's say I want to create a resource pool for those marketing people. Right? And those marketing people need to have, I don't know, 7627 megahertz of CPU and not all that RAM. We want to give them a little bit of RAM. There's some RAM. So now I've created a resource pool, and those marketing people can now do whatever they want as long as the amount of resources that they use are equal to the amount of resources that or less than the amount of resources that I've assigned to that resource pool. Now there's no VMs in here. Right? If I take a VM and move it into that resource pool, right, now I'm going to have resource utilization. I power on this VM, I'm going to make use of this. So I'm now essentially providing kind of some hard limits for those marketing people so that they can create as many VMs as they want, as long as the VMs that they create don't exceed the reservation that I've limited them to. Okay, I can create sub-resource pools too. The marketing people want to go through here and, I don't know, Project X people. So they can then, from the reservations that I've given them, then give more reservations, and it can go on to infinity. So this provides a way to take the sum total of all the stuff that makes up that cluster and break it down into logical separations that make sense from business rules. And that's why you create resource pools. And we'll get a little bit further in a future nugget into permissions and then how you might assign permissions into these resource pools. You think about it, right? It doesn't make any sense for me to create a marketing resource pool unless I give the marketing people the permissions to do stuff, right? So we'll talk about that a little bit later. But this is the last piece of a cluster, which is, all right, I want to chop the cluster up into little bits, and then those bits are equal to how many resources I want to assign. So this kind of takes us into the final topic for this nugget, and that topic really is this whole notion of extending the cluster concept into the data stores, right, and into the storage. And turning DRS, which was for a very long period of time just focused on the brains of the VM only, into something that can operate for both the brains and the body of the VMs in this thing called storage DRS. Now, a lot of storage DRS, it's the same kind of concept that we've already talked about as it relates to regular DRS. You got to have storage, you got to have enough storage, you got to have places for storage to go. Where you will actually configure that storage is here under data stores and data store clusters. Now, you'll see all the different data stores that we've created. You'll notice here that I actually have two more data stores that I've created, data store 2 and 3, that are currently available and attached to by all three hosts. And I've done that because I want to create a new data store cluster. I'll call it my data store cluster and turn on storage DRS. Now, remember, DRS is load balancing. Okay, a data store cluster is a bunch of different data stores that I've aggregated together so that I can load balance the use across those data stores. So I can either do automation, or I can do, in this case, just only full automation. I'm going to leave it at no just for now, just to make things easy. And if I choose next here, I'm skipping over the advanced button because there's not much to see there. A data store cluster. And this DRS pieces that are doing all the moving around with a data store cluster. The idea here is that your data stores can become unoptimized for one of two reasons. One is because you've got too much space in one side and you've got not enough space on another side. So your space utilization, your consumption is imbalanced. The other is that you've got too many machines that are trying to run too many things against one data store, and another data store is sitting here pretty much doing nothing. That's I/O latency based thresholds. And these are what these two are here. Now, you can turn off the I/O metric for recommendations, which means I only care about capacity. I only care about utilization. I don't care about performance. If I turn on this metric, I'm going to turn on that storage I/O control, if you remember that from a previous nugget, on all the data stores in this cluster, so that now I'm going to actually SV motion my virtual machines around based off of if I'm running low on space, or if I've got one data store that's just getting too hot and too many machines are using it. Kind of a neat idea here. When I do so, I got to figure out what my thresholds are, 80% for utilized space, and how many milliseconds of I/O latency I really care about. When I enable these, that will begin to move things around across the different clusters that I have. If it starts to notice that virtual machines are not getting the IOPS that they need, or if my clusters are getting to be too populated. So let me just pop all three of these data stores into this cluster, choose next, and finish. And that essentially creates the data store cluster. Very simple, very similar to the DRS cluster that we saw before. So now I've got this real nice data store cluster with all of the capacity of these data stores aggregated into one place. You know, I got 234 gigs of space there across 3 data stores. The other 2 were fairly small. I've purposely created these in a way because data store 2 and 3 are about 1/10 the size of data store 1. So you can see here that the largest free space is 187.51. Now, when I create that cluster, just like before, there are going to be some settings I have to also be aware of. Okay, here are my advanced options if I wanted to. I skipped over those earlier. What I'm looking for here is the scheduling. Okay, when do I actually want to schedule SDRS to do settings changes? You know, in the middle of the night is when a lot of this stuff can happen. And the reason for this is because, remember, a vMotion takes just a minute or two, maybe a little bit more. An SVMotion can take a really long period of time. So I've got to set this to happen, you know, when I'm not necessarily going to be around, so that I can not impact what's happening to my regular cluster. Okay, my end settings. I don't want to be SV motioning stuff around in the middle of the day. It's just not really a really good idea. I can also set rules for those virtual disks just like I did before, same kind of affinity and anti-affinity rules. What this, in a lot of ways can do is it can protect myself against, I got 2 different data stores that are both my mission critical data stores, right? And I want to make sure that the VMs that are using those don't somehow get on the same data store, because those VMs are, well, they're really, you know, they're very hot. Because they're mission critical, you're making a lot of usage of storage. So I can set up either a VM or a vmdk anti-affinity rule here. Notice how there are no affinity rules. There's no need for them. All I want to do is protect VMs and VMDKs from ever being on the same data store so that I don't end up with some really bad contention that I ended up creating myself. Lastly is the same thing. Do I want to keep those VMDKs together or separate them apart? I can do so here. This has to do with, well, the virtual machines, the VMDKs for the virtual machines. So these are the settings for that cluster. Once I have stuff in there, in that cluster, then I have the ability to, you know, move things around if I need to. And that's really all there is. I mean, those are the activities that are associated with creating that cluster. So what have we talked about in this nugget? We have talked about all of the extra stuff that layers on top of vMotion and SVMotion that relate to adding some intelligence, some automation to the vMotion, SVMotion activities. We talked about VMware clusters. We talked about how in order to set them up for HA and even for DNS or DRS, you have to be smart about that. You got to be real smart with how you build those resources. And we also talked about EVC, because you could create islands of vMotion capability to protect yourself against not being able to vMotion. And then we went through the process of creating a cluster and resource pools and adjusting the shares, reservations, and limits for resource pools, and how to monitor some of the behaviors and what those behaviors are, and also how to configure storage, DRS, and data store clusters. I hope this has been informative for you, and I'd like to thank you for viewing.